A moon orbiting a planet, a spinning Ferris wheel, a yo-yo trick called the world's first, the International Space Station. They've all got at least one thing in common. Find out how they all come together. Full circle next on the real world. Circular path. The curves of a Ferris will also revolve around a central point. And, of course, when you go around the world with a yo-yo, it's going to spin around your hand. And why does all this happen? It's because of a little thing called centripetal force. Basically, centripetal force is a force that makes an object like planets or other satellites in space follow a curved path. The word centripetal means seeking the center. What better place to be studying centripetal force compared to the largest artificial satellite in space, the International Space Station? In addition to actually experiencing centripetal force, the free-fall environment aboard the ISS allows for some really cool demonstrations, so let's send it out. For Expedition 22 astronaut Jeff Williams, this is a tool. This is a special tool that we use aboard the space station, actually, during spacewalks, but this is a heavy metal object, and that's what I actually do. I wanted to use it, and you can see that I've tied it to a string, or with a string right here on this bungee. And it's just floating here. Weightless, and you can see the string here. It's rather loose, and it's just kind of floating randomly. If I were to spin this thing around this bungee on the string, and let me do this, you can see that the string pulls and stays tight and the tool keeps spinning around the bungee. In fact, if you look really close to the bungee, you can see that the bungee bends at the point that it's rotating, and it bends towards the tool, and that causes centripetal force is caused by the angular acceleration of the tool as it rotates, holding the string tight and maintaining the rotation in a circular motion. It's the same type of force. It applies to rotation of planets around the Sun, or the Moon around the Earth, or a space station around the Earth. But you notice, it can be found that neither the Moon nor the ISS are connected to the Earth by a string, and they are still orbiting. Why is that? Well, think about it. The satellites will continue to move in a straight line due to inertia. Remember that inertia is the tendency of an object to keep doing what it was doing. Something forced it to change before. Gravity is a force to cause that change. Satellites in orbit around the Earth are being pulled toward the Earth by the Earth's gravity. Acceleration events are caused by gravity constantly changing the direction of the satellite. To understand how this works, let's take a look at this. I've got a yo-yo, and I'm going to spin it around my finger on this table. The string here is acting like the force of gravity. If I let go when the yo-yo is at this top point, where do you think the yo-yo is going to go? Inertia is going to take it. Will it continue in a circular motion? As you can see, the yo-yo wants to move forward in a straight line instead of a curved one. It connects. The string is just one thing. It holds the yo-yo in its circular path. The string mimics gravity. Similarly, the ISS is held in orbit by Earth's gravity. If, for some strange reason, Earth's gravitational pull were to disappear, the ISS would continue in whatever direction it was moving. Here's Jeff with another demonstration of centrifugal force. Okay, I have this tea bag, and it's got tea in it, of course, and it's got air bubbles in it. They're floating around. The bubbles don't rise to the top in the absence of gravity, in this weightless environment of the space station. But if I were to rotate it, and let's see if I could rotate it, and keep it in mind for the camera, let's see what happens. If you look really close, you'll see air bubbles. The union is starting in the center of the tea bag. I'm going to try it one more time. There are bubbles spread throughout the tea, and if I spin it, the bubbles coalesce to the center of the tea and eventually form a circle. Why do they do that? The centrifugal force causes the tea to expand throughout the tea. The liquid tea goes to the outside of the bags, and that forces air out in the center. Because air is lighter, less dense than liquid, so air moves toward the center. Centripetal forces affect things here on Earth as well as in space, things like a Ferris wheel or the speed of a car going around a bend. But what are the other applications? Is this force in space You've probably heard a lot of talk about artificial gravity in space exploration. You've probably seen it. Some science fiction movies, for example, Star Trek, TV shows and movies, they had gravity on board. They had some kind of a mysterious artificial gravity, believe it, of course, but we've talked for years about artificial gravity aboard a spacecraft, especially when you're going for a long period of time for various reasons. One of the ways you could do that is to create artificial gravity, because it's a space station that rotates probably very large, and the larger it is, it would have to rotate slowly. To create that centrifugal force, Jeff said it's big. The station will have to rotate slowly to create that artificial gravity. You need centrifugal force to create that artificial gravity. To find out why, we need to check the math. Centripetal acceleration is equal to the square of the object's velocity divided by the radius of the object. Spin is velocity divided by radius. Radius is distance. From the center of the circle to any point on the circle, spin and size of the radius are actually inversely proportional. On a rotating station, the larger the radius, the smaller the rate of change required to simulate gravity. Theoretically, you could do that. Theoretically, you could take a large station and produce, through centrifugal force, an artificial gravitational configuration to keep everything in its place, but the problem with that is when it's not very practical, because when you rotate something and we turn our head and neck, our vestibular system is going to get a little bit messed up. And that's what happens if you're going on a happy ride, and then you leave the thing. Or you wander around until you get dizzy. It would be the same kind of thing. So I'm not sure. Artificial gravity is very practical in that way. Wonder who will be the first to create artificial gravity. But hey, don't just sit there and spin your wheels. Use this math to help you solve this challenge. I'll see you next time on The Real World.